Construction tech students, this is the second video I'm doing to show you how to figure out the values that you need to lay out a common rafter. I am not going to give you quite as much guidance this time around. I'm just going to walk you through the process. So remember, these are the characteristics of our situation, and these are the things we got to figure out in order to lay out a rafter. Once you do all this, laying out the rafter is relatively straightforward, but you got to figure some things out first. Anyway, remember our adjusted span is just our overall span, subtracting out the ridge board. And in our case, the ridge board's always going to be 1.5 inches wide. And it lists it right here. Your ridge board is a 2x8. Remember, a 2x8 is 1.5 inches by 7.25. And I know that's a little confusing for people, but I didn't make up all these rules. You got to just remember things. It's just the way it is. So this minus 1.5 inches is going to be 12 feet, 7.5 inches. That is your adjusted span. And remember, our horizontal run, remember each rafter in a gable roof, this is for a gable roof. Each rafter in a gable roof covers half of this horizontal span, this adjusted span. So we got to cut this in half. So the run of the actual rafter is going to be half of our overall run, or our overall span. Remember, we're using run and span kind of interchangeably. So half of 12 is 6 feet. Half of 7.5 is 3 3/4. Again, I could go through how to do this math. I assume you've been through math class. You guys can do some simple fraction mathematics. But if you have to, write it down, or again, download a construction calculator that will allow you to type fractions in there, or convert these fractions to decimals. So this is actually 3.75, right? This is actually 7.5. But when you get really funky fractions, you got to divide the numerator by the denominator. So 9/32. If you want to know what that is in fraction form, what I would do is I would take a calculator like this, or on your phone, it doesn't matter where it comes from, and divide 9 by 32, and it gives you 0.28125 is the fraction for 9/32. Okay, that's a little bit, but then you would write that down. It would be, if this was 3 and 9/32, it would be 3.28125. I don't have an easier way for you at this point. And you have to be willing to do some of this stuff. Okay, so anyway, what we do is we take these numbers and we put them into this calculator right here. What we're trying to figure out is this rafter size, because we can't figure out any of this stuff down here unless we have this. So we got to use two different calculators. So we're going to take some of these characteristics here and plug them into here. So I'm going to switch back and forth between these two. So right here, you guys have all seen this. If you haven't, you really haven't been paying attention. Span calculator, we got to put our species in here. If we go back and look, our species is SPF, and our species grade is number 2. So it's number 2 SPF. I'm sorry about the announcements, but this is SPF. Just scroll down to SPF right there. Say done. Grade is number 2. We're usually going to either have select structural, which is a little bit better, and number 2. I don't really give you either one of those. Our required horizontal span is what we figured out right here. That's why we figured it out. Okay? This is the distance horizontally that our rafter will cover. Remember, our rafter covers half the overall in a gable roof. Okay, so 6 feet, 3 3/4. Whoops, I did hit the wrong thing here. So right here, and remember, you type it in here. This is a construction calculator. You got to go 6 feet, 3 inches, 3/4. And then I'm hit done. So then I go back. If I could switch back there, but it says rafters snow load. And I honestly don't remember my next one, so I'm going to go back. So there's my snow load, L480 deflection, 16 inches spacing. And then we go 40 and 10. So let's go back. We did L480, 16 inches, and then we did 40 here, for our live load and 10 there for our dead load. And that's all the information. It's literally just double checking and making sure you get the right information in there. And hit calculate. And here it tells you what you typed in, and then it tells you the building member you need. You need to use a 2x6. So right here, our rafter size has to be a 2x6 with those characteristics or this situation, and that run for our rafter, it has to be this size. It can be a little bigger it can be bigger, it just can't be smaller. And that is actually, remember, 1.5 inches by 5.5 inches. Okay? So now we use this information and this information to open up this calculator and type this information in there. So again, I think the rafter run to our outer wall was 6 feet 3 3/4 inches. I don't have to change to 3/4. If you need to look at that, that's this right here. Okay. Our pitch, I don't remember our pitch. Our pitch is 612. Let's just look at this. And some of this we should be able to remember. So this is 612. Our overhang is 14 inches. Now, what you need to understand is this doesn't go to 14. When you get to 12, it adds a foot here. So 14 inches is 1 foot, 2 inches, right? Then it talks about rafter depth and rafter thickness. Well, that's exactly why we figured this part out. This is our thickness, that's the width, and this is the depth, how tall our rafter is. So this measurement right here is 5.5. It's already set at 5.5. The thickness of it, the width of it, is going to be 1.5. And then the last thing we got to set is our bird's mouth seat. And it tells you that right here. So that's a 3.5 inch bird's mouth. Okay. Our wall is 4 inches thick. Our wall height is 8 inches, or 8 feet. Then you get calculate, and it gives you all the information. I don't know if you saw it, but all these numbers changed. Okay. And now I'm just going to tell you this is our diagonal. If you've been paying attention, you should remember that this is like we would have a ridge board right here that this attaches to at the top. So the distance from the very top of that down to this imaginary wall that comes up this imaginary line that comes up from the edge of our wall right there, that is the length of our actual rafter. Okay, but we have an overhang of 14 inches. You have to add length on for that overhang. So our total rafter length is going to be this number plus this number, because this is from here to here, and this is from here to here. They do that for you by giving you the rafter top length right there. They add those two together right there. So write that down as your diagonal. 8 feet 4 and 11/32. 8 feet 4 and 11/32 of an inch. Okay? So that's your diagonal. That is how long you're going to make your rafter. Come back over here. This is my hap. See how when we cut our bird's mouth out of our rafter right here, the distance from the top of that to the top of our rafter is called our height above plate. This is the top of the plate on our wall. So that's 4 and 13/32 inches. So 4 and 13/32 inches. Now that would, for us, we just list this, right? But if we used a different method, there's more than one method for finding these numbers. Okay? This is probably no harder or no easier than other methods, but they all require you figuring things out and keeping a process. So if we swap this they have charts you can look on, they have just computational methods you can use. So it's a little bit easier in some and about the same as others. So, if you talk to a carpenter, they might do it a slightly different way, but there's still going to be quite a process to figuring this stuff out. Okay, so the other thing I need is rise plus hap. I don't know if you guys remember me telling you this, but the rise is actually, there's a parallel line that goes from right here, right up this rafter, and will end like right there. That is your rise. So from there down to the top of your wall is actually, that's what this number is. But that isn't really what we need. We need our rise. And then if I go from here and I draw a parallel line, if I add this distance in, I'll get to the top up here. So we need our rise plus our hap. That is always this number right here. So that's what we write down on our rise plus hap. 3 feet 6 and 9/32. Right there. And that's all we need off of this. The last thing we got to do, what we're going to do on our last thing is figure out how tall do we need to make our post height here. We're going to build a post from the top of our wall here up. And remember, there's going to be a 2x8 ridge board right here. So that 2x8, so I know the distance from the top of my wall to the top of my peak. I just subtract out the height of that 2x8, and that's how high I will make my post. So when I go back here, I just subtract out the height of this ridge board, which is a 2x8 is actually 1.5 by 7.25. So I have to subtract my 7.25 inches from this number. Okay, now this is where I think people struggle sometimes. I'm not exactly sure why it's quite as hard as it is for people, but so if I have 3 feet 6 and 9/32, and I got to subtract 7.25, obviously this is bigger than this, so I gotta, just like any other math, how many inches are in a foot? 12. 12 plus 6 is 18 inches, right? And then I have 9/32, so 18 minus 7 is going to be 11. How many 30 seconds is a quarter? Well, 1/4 equals 2/8, which equals 4/16, which equals 8/32. These are all equal. So 9/32 minus 8/32 is 1/32. So if I do this math, I'm at 2 feet 11 and 1/32 inches. That is what my post should be. So I just take that and I go 2 feet 11 and 1/32 inches. That is my post height. Okay? That's that. That's how you do this. It requires a process and it requires attention to detail, but it is not that hard. Okay.